Today's lecture is the muscular system.
I didn't know what to do with it.
All right, two things about the muscular system. First of all, what are the jobs of the muscular system?
To move the balls.
Yeah. So first, jobs. Things that these do for a living. One, movement. All movement, I can't think of a single exception. All movement in the body is done by muscles. Movement. Moving of skeleton and internal organs. Right now, your breakfast is moving through your body.
What breakfast? No, I'm just kidding.
Oh, and supper from last night might still be moving through the body, unless it's found its escape. Yep.
Moving.
Yeah, it's moving through there, and it's moving because muscles are moving it. Your intestines are lined with muscles. Okay. But the other thing, arguably more important. Anybody know what the muscular system is super important because it has to do with temperature. Okay, heat.
Good job, Marge.
The majority of the body's heat is generated by reactions in the muscles. It's easy to figure out if you've ever done any kind of athletic activity or just even ran away from something. You breathe faster, and if you, in any short amount of time, working really hard at something, you start generating heat. I heated my home with wood for quite some time, and I'd go out on a really cold day with a chainsaw and be cutting a bunch of wood and splitting it, and it wouldn't take very long of doing that. I'd have to take my coat off, even if it was 30 degrees outside, because generating so much heat from muscle movement that I don't need to trap it anymore. I need to actually displace more than I'm trapping in that instance, because the muscles generate a tremendous amount of heat, even at rest. Our body is a toasty 98.6 degrees, mostly because of the chemical reactions happening in the muscles. As a result of this, having muscle is expensive.
So, like, if you ever get in your car and it's cold, and your muscles start like shaking.
Yeah. That's the goal of it, right? Because contraction of the muscles generates heat more than they do at rest. So yeah, that's why we shiver. That's exactly right. Having muscle is expensive. Wow. What in the world could I mean by that? That doesn't follow the logic of any of these lectures that you probably see.
It takes a lot of nutrients.
Yeah, that's exactly right. Muscle consumes an enormous amount of energy at rest, and even more when active. Okay? So, the thing is, gang, I know that when, like, on Biggest Loser, girls are on the thing are frustrated, the guys seem to lose weight faster. This is why. Generally speaking, men have more muscle on their frame. So eating less calories, just having more muscle means the body needs more to consume just for that purpose. Athletes that have a lot of muscle on their frame eat a lot of food. I remember I used to read Muscle and Fitness magazine because I worked at GNC when I was in high school, and nobody ever came in the store, like, ever. So I just read through all these magazines, and some of these guys were eating like 8,000, 9,000 calories a day. I mean, their legs look like someone pulled skin over like a 26-pound turkey. That's my leg. It's like, what? But that is expensive. It really is. It takes a lot of energy just to keep these muscles going, which is why the body doesn't really want to keep this around unless you need it. Unless you're like Hercules or you're in charge of guarding Sparta, your body doesn't want to keep muscle around a tremendous amount, because the body is efficient / lazy. Okay? You can look at it one of two ways. Kind of like I give you tests on Canvas because it grades them for me. That's efficient. Some would say lazy, 60-40. Okay? It doesn't want to keep more energy consuming tissue than it needs. Starve yourself out, trying to lose weight. You will lose fat because it's a lot of our calories are stored as fat, but you'll also lose muscle. One, because it doesn't have the energy consumption necessary, but the body also deems it as an unnecessary resource if we have all this extra muscle. There is actually really specific science to starvation. Try to avoid it if you can. All right. Let's see here. Muscle is contractile tissue.
Wait, tell me what happens when you starve, other than the obvious fact that you get finished.
The body takes certain things in order depending on how long you're starved and how much extra resource you have. It doesn't want to take away or consume vital things like brain and organs and things like that. But it will take from those at the end when it runs out of other options. Your body does eat itself. If you think about it, you store fat for the purpose of later consumption. And ideally, we're hitting those resources first, but it kind of takes a little from everything. It preserves the things that are vital to life until it has no other choice. So that's why. But again, it's way more specific than that. If you're really curious about it, Google science of starvation and figure out what happens with that. But yeah, not eating at all, though technically you can lose a lot of weight that way, not a great plan. It's kind of like you can cut off your leg and lose a whole lot of weight at once, but not really a super great plan. Okay, muscle is contractile tissue. It moves us by getting shorter. Muscle can only pull. It can never push. Well, that doesn't make sense, Mr. Helly. Bench press is pushing, and squats are pushing, and leg extensions are pushing something. What do you mean? Even when we push, muscle tissue itself is pulling. Okay, if I push a bar and bench press, my pectoralis is pulling my humerus toward my midline. My tricep is pulling my ulna straight. Muscle only works by getting shorter. It doesn't ever, muscle itself is too squishy. It can't push stuff. So because of this, we have muscles that work together and we have muscles that oppose one another. We have in excess of 600 muscles in the body. If muscles work together, they're called synergists. Good example is the quadriceps. We got 4 muscles that are doing the same thing. If Vastus medialis, vastus lateralis, vastus intermedius, rectus femoris, all doing the same thing, straightening the leg. Okay? Things that require a lot of energy and a lot of strength will have synergists like that. Things that don't require a whole heck of a lot, like, turning your neck from side to side, it's really only one, sternocleidomastoid. But then there's other ones like this, antagonists. Muscles that oppose one another. Okay. The examples here, all four of quad. An antagonist would be the biceps and the what? The triceps. One of them is working to flex the arm, one is working to extend the arm. Okay. All right. So all four muscles of the quad are synergists. Antagonists is muscles that oppose one another, like the biceps and triceps. Okay, this is a reasonable place to stop for today. Any questions?